Hello everyone, once again we're back here on CodeForces. This is a Division 4 round. Check out the other rounds and the other videos on my channel as well. We do these rounds, so I record them, and then after the round this video will be uploaded and available on YouTube. So this is the first time I see that this many people here on Division 4. I mean, on any round, 34,000 people is a lot. By far a lot, I think, on CodeForces. I'm using this CPH Judge here, this extension. I will talk in a future video about my competitive programming setup. Also, I would note that because it's a Division 4 round, the tasks are only tested on some pre-tests, and then after 12 hours of hacking, I think, of the hacking phase, there will be system tests. So some code that I will show here may fail on system tests. That sometimes happens because of like silly mistake somewhere. I just want to here just go over the tasks and explain them. After that, these silly mistakes can be fixed fairly easily. So someone has 3 digits. He asks you to determine if you can choose any 2 digits and make a sum greater than or equal to 10. That's a pretty straightforward task. So we have 3 digits, A, B, C. And then I will say that this is like false. Then OK will be either A plus B is the sum greater or equal than 10. So it's A plus B, C plus B, or A plus C. A plus C here. You can choose any 2 digits and make a sum greater than 10. So I think I will be using these like lightweight versions of CodeForces because the heavy version of CodeForces just, can I submit here? Ten words of wisdom. In the game 10 words of wisdom, there's n participants from 1 to n. Each of them who submits the right response to AI words, and has PI quality. No 2 responses have the same quality. At least 1 response has length most 10. The winner of the show is responsible, which has the winner of the show is the response which has the highest quality out of all responses that are not longer than 10 words. Which response is the winner? Just a simple. First we read n, then we say that there are A and B here. So this is like int max quality. Can this be negative? No. So if B is bigger than max quality is B, and then the length. So what do we need to print? For each single integer and the winner of the show according to the, so answer -1, so answer is +1 here, but this also has to be A has to be that are no longer than 10 words has to be smaller than 10 here. So if B is maximum bigger than this, Okay, this passes. Let me just submit this. Let's go. An 8x8 grid. Well, that's a word consisting of floor is written in one of the columns from top to the bottom. What is it? 8x8 grid. Okay. In one column. So I'll go through the columns, and as soon as I see a word, I will just so I will read all of the lines here. I will reading all of the lines. Then I go through all of the columns. I go through all of the rows. And then I see if g of I j is not equal dot. So if it's not equal dot, then I will start from the ith row and then go down. I will do this. If g of k of j is equal dot, then we break, and then here I will just see on end line and I will return, and this should work perfectly. Okay, balanced round. You are the author of CodeForces round and paired end problems. You're going to set problem I has difficulty AI. You will do the following process: remove some problems from the list, rearrange the remaining problem in any order. A round is considered balanced if and only if the absolute difference between the of two consecutive problems is most k. What is the minimum number of problems you have to remove? First of all, we can just sort the problems, and then we can see that so there's n and k. I haven't checked the constraints. This I think was good constraints. So n and k, k goes up to 10 to the 9. So I will read the problems. I can sort the problems because I can rearrange it in any order. And then what is the most do we start from the median problem? That's the minimum number of problems we have to remove to rearrange balanced. So I go here, there's like one block of problems, and there's some other block of problems, there's some other block of problems. So I divide on all of these blocks of problems, and I choose like the biggest block of problems that if I is equal to 0, or A of I is the absolute difference between A of I and what is this? Is at most k less or equal than k. So A of I minus A of I minus 1 is at most k, and then current plus plus. Else, so current is 1, biggest is max biggest current. So this is like the biggest block. This is also here. Okay, and then we say that it's like this. I think that should be quality. I think that should be it. Unexpected error, what the f. Okay, cardboard. Has end pictures, diet picture has side length of SI centimeters. He mounted each picture on a square piece of board. So this is square and this is square. So each picture has a board of W centimeters on all sides. Use C square centimeters of cardboard. Given the picture sizes and the value C, can you find the picture size is N? No, the picture size is, there are N positive integers and C is the So C is the total number of square centimeters used of cardboard. So C is the total number of square centimeters used. SI are the sizes of pictures. So W is not big. So there's like N, there's C, and then there's sizes of the paintings. So the sizes of the paintings, each painting, so W here is not a lot. Okay, so if you have like one painting, and then you have like one size, W can be the up to square root of 10 to the 18. Like one, two of these. Pictures, let me just see. W is at least I mean, W is just like wait, it doesn't, I see. It kind of doesn't matter this, so it matters like how do we calculate given a W and a wait, how do we calculate this? As I understand, this is five squared. W is 1. C is 55 squared. No, so yeah, W covers like the whole thing because this is 5, this is 3, and this is like 1 and 1, 5. So it's 5 squared. That's 4 squared plus this 3 squared. So the thing here, the equation is that the sum of like AI plus 2 times W squared, this is what we want, the sum of these, to be equal to C, right? Okay, so this can be rearranged and says sum of AI squared plus 2 times AI times 2 W plus 2, so 4 W squared. Okay, so this can be pre-calculated and can be taken away from C. This here cannot be. So how do... Okay, so this is like some equation. We can binary search on W here, because this has some linearity, right? So I'm just writing a simple binary search. So 2 times mid AI plus 2 times mid squared Can this overflow? Or let's just not use gold, so let's just fail. Two times W, 2 times W. So AI plus 2 times value. If that's bigger than C, or the sum plus C is bigger than C, then it's failed. Okay, so what we have here? We have 3, 2, 1, then times W. Oh, sum plus equals C. Okay, this passes. I think this is correct. I don't think there should be any overflows, but if there are, I will fix it later. We're looking at a group of n frogs, so number from 1 to n. Frog I has a hop length of AI. Each second frog I hops AI units forward. Before any frog starts hopping, can place exactly one trap in a coordinate order to catch all the frog. Okay. However, the children can't go far away from their home, so they can only place in the first endpoints. So they're all frogs located at point 0, and then they have some hopping length. Okay, that's a cool problem. So in what well, n doesn't exceed a lot, so for each of the, so for the first n points, so what we want is the n points is for each point to quickly say how many frogs they're gonna end up at this point, is to quickly say how many of these integers here, AI, are not divisible, but like n, all of the divisors of n, we are going to say how many okay, let's do this. So for all of the divisors of this number, of some number, they're not a lot of divisors, right? They're just like for all of the divisors of this number, I want to see how many frogs are there. So if frogs jumps more than n, then you cannot possibly put this. But so this is like some frequency map that we have, and then for each position from 1 to n, can we include n? The first n points, that is the point between 0 and 1. For each position at 0 and 1, we're gonna go through each of the divisors. And then say that if so sum, if j divides I, then the sum is map at j plus map at I divided by j. If j times j is equal to I, then sum is just map at j. A compass has these direct, and there are n distinct points with integer on a plane. How many ways can you put a compass at one point and the morning star at another so that the compass does not break? It can only point of 8 directions, the 4 cardinal directions, or some combination. Otherwise it will break. So it can only point like this, and then there's some points. Each point, there's some points, and it says Okay, so here's something with GCD. So in order not to break, is either like for each point I need to quickly know how many points are on the x-axis the same with this point, how many points are on the y-axis the same with this point, how many points are on some of these two diagonals. Okay, yes. So for each point, I go for points that are on the x-axis. So I have some map there. I have some map that points on the y-axis, and I have some map. How do you do this thing for the? So if there's like some point here, then some point here, the difference between these 2 points, the read the points. I have a class for points, so I have this class I can use. I will figure this out quickly. Frequency x, frequency y. Then I need to know, so this line, how can be, so this line has a constant factor of like 1, right? X plus n can be defined this line. So technically I just need the y coordinate. So I need the y minus x coordinate is that, no, y minus x coordinate is the, yeah, the y minus x coordinate and the x minus y coordinate. Is that true? X minus y coordinate is like how much do we shift or is it just quickly to draw here. So this line here is this coordinate where it's like on the y, so this is like x and y, and each other point here is the same as I'm saying if I kind of from x I kind of minus y here is this point. They all have this, like from the x I will cut off the y, right? And the other way around, I think. Then the answer is like frequency at x points I x minus 1, and then frequency at y minus 1 because I don't count myself. Oh, we count multiple times at some point. Wait, how do we count multiple times at some point? No, this is not correct. X and Y. This. So yeah, so this here. My x minus this y here is this point. The other side is plus y. So like x plus y. Okay, this seems correct. And the last, third ladder. In order to win the toughest battle, great strategy, there's n soldiers and decide to arrange them in certain camps. Each soldier belongs in exactly one camp, and there's one camp at each integer on the x-axis. Let me just refresh it. Here, let's see the standings. Of course, we just have problem H to solve. Each soldier has to belong at exactly one camp, and there's one camp at integer point on the x-axis. So, okay. The strategy consists of m conditions. The condition I tells the soldier AI should belong to a camp that is situated di meters in front of the camp that person BI belongs to. Di should be minus the behind the camp. Yeah, so okay, so alright, so you have some condition that AI and BI are connected with. Wonders if there exists a partition of soldiers that respects the condition and asks for your help. Answer yes if there's partition of the n soldiers that satisfy all of the m conditions and no otherwise. The condition I tells the soldier AI all of the m conditions. So this says like soldier 2 has to be behind this soldier. It kind of doesn't matter. It like only matters like you do like a graph, right? So 1 is connected to 2 is connected to 3 here, like 4, and then 4 is connected to 2 with -6. So this says yes. For the first case, we can partition the soldiers into camps in the following: soldier 1 in the camp coordinate x, soldier 2 in camp coordinate 5, okay, soldier should belong to campsite trade in front of the person. So this should be in front of the person. Done. Yeah, so okay, so doesn't really matter. Okay, so negative signs we can just flip this, make like a directed graph where you would kind of, okay, so what about this partition? So wonders if there exists a partition of soldiers that respects the condition. And he says, okay, so let me see here. Okay, this is yes. There's no partition that can set this. Partition means that like whatever we choose this, okay, this is bad translation. I think I thought that like you could choose some subset of soldiers, but not like it doesn't mean that it's a subset, but it means that like yeah. So apparently this means like all of the constraints have to be satisfied. Okay, so the first thing you do is you kind of say where are these soldiers. So each soldier should be like pointed somewhere, like so let's say -1, and then where on the first guy should be like 0, and then these are like edges here, so A, B, U, V, and then like the distance. If distance is negative, then we say that the distance, we make it positive and we swap U and V. And then what we say is that, so U minus minus B minus minus, of course we just want 0 indexing. First it might not be given 1, but okay, so here's the idea. We want to have some adjacency list, and this adjacency list exactly will say like adjacency of U push back to V with this distance. So this will be that. And then you will say that okay, yes, adjacent U okay, it's like true. Then we start, like we can do DFS or BFS. I will do practically BFS because it's easier, so I don't have to code. I mean, I don't want to make it recursive, so in the queue I will push 0. I will then say this. So I'm getting my element where he is, and I'm saying, okay, for all of these like other guys, I have to make them for all of these, for all of V and the distances in adjacency of T. I have to check if they kind of make sense. So if where at V is not so wait, but what if So this is, that should be like that. And then here I have to say, okay, is it visited? Because this could this could very well be like one can only be here. Very well could be like I want at least everyone to be here as well. So where v is not, if where v is -1, then where v is where that t is plus d. And then in the queue I will push v as well, and then I will continue. If where v is not, so if it's not -1, so it's not -1 and it's not where t plus d, then q dot then okay is false. So or cout no return, and here I want cout yes. So I think that should be for h. Let me just test this out. Okay, so run cancel on test 2. Yes, if there is a partition of n soldiers, satisfy all conditions. This is not even needed. This is just fine, so having minus here. Q, then Q push V. Because it's a metric, I don't care if it's like minus or not minus. Wait, the fourth test case says that there are 4 soldiers, but all of these are like that, so there's no condition behind it. So should be fine, like if there are more soldiers, should be fine. The only thing is like when this condition is reached, so where v is not equal to t plus d. It's already set, but where this is not equal. So oh, of course, so here I need to search through all of the components. It doesn't like it doesn't necessarily mean that. So if where at I is not -1, then we want to continue, otherwise want to push I, of course. this is our mistake, so I want to why is it no now? This should now work. Oh, it's the wrong answer. I don't get this. Of course, minus. It's not -1, but if so we need like visited vector again, because something can be, if it's not visited, then we say visited I is true, and here visited of t is true, because there could be -1 here, and then here, if it's not visited, v, then this. So if it's not visited, if it's visited, I will continue. Then we'll say true here, then there's 0, then there's like visit of t is true. Okay, so I think this should work. So I will just go quickly through the solutions so I can upload this video, and as soon as the contest finishes I can just make it public. That's why I can it's still testing. Okay. Okay, it gets accepted. The system tests will then, after the hacking phase, may result in some wrong answers, but I don't think the most problem I assume there could be an overflow is this here, but I don't know how strong pretests could there be. So if there is overflow, because I'm out of competition, I don't quite care right now. But if there's overflow, you can fix it by adding integer 128 here where the sum is, and then after that, this won't be even needed to check for overflows. So yeah, so we solved all of them in an hour. Let's just go through the contest once again for you guys to to explain all of the solutions. So the first problem was just asking if two of these three numbers, give a sum greater than 10, and just you could do this on many different ways, but the most simple way is just to copy paste here 3 different conditions. If if first false, then either any of these are true, then will become true, and then you just test for is it false, or, is it yes, or is it no. So this is pretty much it. The second problem was asking, so the second problem was, I don't know if it's too loud maybe, but the second problem was asking about there are n words, and each of these words is like AI long and has quality of BI. So you had to see what is a word which is shorter than, which is no longer than 10. Oh, it's not a word, it's a response, like this response. So there's some n responses, and with each response is AI words long and has a BI quality. So you have to find from all the responses that are no longer than 10 words, the one which has the maximum quality. And what I'm doing here is I'm just remembering the maximum quality and what is the answer. So the answer at first is like -1, that doesn't exist such word. Then it's always guaranteed that there exists such a winner, but it doesn't matter. So then we read A and B. Remember that the A is the word length and the B is the quality. If the quality is bigger than the maximum quality and A, the word length, is smaller than or equal than 10, then we can update the maximum quality and update the answer with a new winner, I. There is going to be a distinct winner due to the distinct nature of the quality. So each quality is a distinct integer. This is task B. Task C is just reading a simple 8x8 grid. So I just have vector of strings that are 8 strings, and each string I read. So each line I read it as a string. Then I go through each column, then I go through each row, and I see that if I detect a letter that is not a dot, then I go along this column, and I see, while I don't detect a dot, I will just print out whatever in this column it is. Then I will end line and return. This return will return from the test case function, thus making it just simple, compact. So after this return, it will no longer process this test case and will go to the next one. That's pretty much it for C. For D, the balanced round, so there are n problems to set. Each problem has some difficulty AI, and you need to do something like this. So you can remove some problems from the list and rearrange the remaining problem in any order you wish. But here you can really quickly see that if I can rearrange any problem in any order I want, the best order I can rearrange them is sorted order. Why? Because it's like here you ask this question: a round is considered balanced if and only if the absolute difference between the difficulty of any two consecutive problems, so consecutive, so in this order, is at most k, so less than or equal than k. And then what is the minimum number of problems you have to remove? So you have to remove some problems, or you can leave it all, but so that the rearrangement of the problems becomes balanced. Okay, so it's simple that the rearrangement of the problems is balanced. It's probably going to be in some order that is sorted. It's kind of easy to see that, but let me just explain. So if you have like this graph, and like each problem can be denoted as some dot here, this for each problem is like here, and then the height of this dot denotes the difficulty of the problem. So bigger dots have bigger difficulty, so higher dots have bigger difficulty. So if it's not a sorted order, what you can do is this problem will kind of not affect anything here, will actually make a bigger absolute difference than this here. So I can move this problem here and thus kind of minimizing the minimum distance between absolute problems. So it's pretty well known fact that sorting something minimizes the sum of absolute differences of all the problems. And then when we sort this, so when we say that this is already sorted, it can happen that there's some like problems here that are sorted and some like problems here that are also sorted, and some problem here. And let's say the k here is like really small, really small distance. So each of these problems go into like k absolute distance. So this problem connects with this problem connects with this, and this, but this is like bigger than k. So this here distance is like bigger than k. And then let's say that this distance is also bigger than k. But these are all smaller than k, so I connect them. So what you can see is that so you can see that it's divided into 3 groups of problems. And you cannot merge these 2 groups in any way. Rearranging the problems won't help, because rearranging the problems from a sorted order to some unsorted order won't give better absolute differences here. So this is like the optimal order, but you want to pick the group with biggest size to remain. All of the other groups will be eventually deleted, so it have to be deleted because they cannot make the round balanced. And I pick always the group with the biggest size, and I say that all of the other problems have to be deleted. And this can be reflected in our code by like, okay, sorting this is the size of the biggest group, this is the size of the current group. If I is 0 or the absolute difference is still inside this group, so inside the k, I will increase the current group. Else I will update what is the biggest group found, and I will say the current that is 1, the current is now the current element is at another group, and then I will again here make this maximization of the biggest, because the current can be at the end like some other value. You have to maximize the biggest again, and then n minus the biggest is our answer, in which like how many problems, what is the minimum problems you need to remove. The minimum problems is the n minus the maximum problems that you will need to keep. So this is problem D. Problem E was this cardboard for pictures problem. So I could just here derive this equation that I wrote. Let me just derive this equation. So first, what was the problem? So you had some like n pictures, and then the cardboard used to make frames for each picture is of this equation. So the picture's length size is like I, let's say like this, and the cardboard adds 2 times W on both these sides, and W is like something that you need to search for. So it adds 2 times W on both sides, and now this is the new length. But then this is of course squared. But you can see that although this is some kind of square equation which has some minimum, right? So essentially it's like this. Because W, this can be only positive and this can be only positive. We kind of don't care about like negative things of this equation. And because this is only in the positive realm, so because all of these are positive, I can search W with binary search, because this is a monotonic function in the positive integers, if W is positive. So W can be seen as some x, some our x that we search for. And because a monotonic function can be searched with, like we can search with binary search, it takes log n time to search across W. And each search will take us n time to go over all of the frames to see how much each frame sums up for our product. So our product will be like the sum over all of these AI plus 2W squared, so over all AI, so from 0 to n, this is our sum. And if the sum is bigger than so there's some c that the sum has to be equal, so there's some c here, the sum has to be equal. If it's bigger than c, we know that the binary search have to look at this side. If it's smaller than c, it has to look on the other side. So this is what I'm doing here. We say that if the sum is bigger than c, the right side has to be minimized. If the sum is else, if the sum is smaller or equal to c, the left side has to be minimized. And in the end, the left side will be a valid. So I don't know what happened. So okay, so this doesn't matter. I will fix the camera. So at the end, the left side will be valid, because the left side has this sum equal than c here. For more binary search tutorials, you can check out the Richto or some other CodeForces blogs. Problem F is okay. So problem F here, we were both children. There are some frogs and they all jump with distinct so they all start at position 0 and they all jump with distinct hops. So some frogs can be like this. Let's say that some other frog can be like this, and some other frog can be like this. And yeah, so all of these, like let's say some other frog is something like this. I don't care about this. So you were asked to find somewhere a spot that you can put a trap for all frogs. And this trap, like if I put it here, so if like the green landed on the same place here, there will be like 3 frogs catched, but this red frog won't be catched. So in turn, you want to so you kind of wanted to maximize the number of frogs. What's the maximum number of frogs they can catch using a trap? And how you will find this is that first we need to see that we just care about up to n, up to this n place. And all frogs that jump more than n, we don't care about, because they will just like go here and no trap here can ever catch them. But for each frog here, what I can do is I can remember what is his period that is smaller than n. So for each frog that jumps with smaller period than n, I have like some map here that remembers, some vector that remembers what is the period of the frog. Okay, and then the answer here is initiated, and then for each of the positions that I can put a catch, I need to see how many frogs will I will I catch there if I put it there. So the sum of the frogs in that position will be equal if I go over all of the divisors of that position. All of the divisors can be only to the square root of n, so this is like n times square root of n, n times square root of n complexity. If this divides n, so if this j divides n, then we have to check if j times j is I. So if that j times j is I, then we just sum up at that position. Otherwise, we sum up at that position plus I divided by j, because there's one more divisor that has to be accounted for here. We know this by simple number theory. And this sum here that is for that position, we will say, okay, we will catch this many frogs, and then the answer is like maximum of over all of these sums. That's pretty simple, I think, pretty cool problem. It teaches you about this n square root of n complexity. The morning star, of course, this is like a bit more geometric problem, but it can be thought of as well as like some mathematical line problem, problems of linear functions. So you have some points here, and then you will need to somehow put here in one. Like, how many ways are there to put like the compass in one point and the morning star here at the other point? And the ways that only need to be counted is such that the compass returns to the morning star in one of these 8 directions. So so point that is like this with this angle here that is not 45 degrees, it cannot be counted. So angles are either 45 degrees or 90 degrees here across all of this thing. Oops, I don't know what happened exactly here. Let me just fix here. Okay, okay, so the camera is back. So it's either 45 degrees or 90 degrees. So all of these 4 directions. So how do you check this? Yeah, you can't just iterate over n squared points, because iterating over n squared points is just a big number. The first thing you can see is that it's easy to check if the points are lying on the same x coordinate or on the same y coordinate. We can make 2 maps, frequency maps, that will remember if there's a point at this, how many points are on this x coordinate. And so one frequency map will remember all of the x coordinates, one frequency map will remember all of the y coordinates of each point. And now checking for each, so going through each point, our answer will be summing up over all of the points that have the same x coordinate, minus 1 because I sum up myself as well. I had the same x coordinate. Here the same thing goes with y. All of the points that have the y coordinate, minus 1 because I have the y coordinate as well. But the diagonals are a little bit tricky, and here where the mathematical equations come into play. The diagonals can be really easily seen by doing this. So if I have some point here, so let's say I have some point here, x, and this is, so I have some point here that has x coordinate, and I have some point y with the coordinate of this point on the y-axis is here somewhere y. Okay, so I want to this diagonal. I want to calculate this diagonal first. I want to find what is the common thing between all of the points that lie on this line here. You can see that this line, if I decrease 1 from x, it will decrease it. If I decrease 1 from y, it should decrease 1 from x to be in this line. So because it's 45-degree angle, one from x decreasing 1 from y, it will decrease 1 from x as well to be on this line. So what I can do is I can say, okay, instead of x here, I want to have like some scalar point, right? And this will say, okay, instead of x, I will, from the x point, from here, from this x point, I will remove as many y as I need to become to here on this, like the intersection between the x-axis here. Okay, so the intersection between the x-axis and this point and on this and this line here is some point which is x minus y. But then there's like this other line which goes something like this. The intersection between this line and this and the x-axis is x plus y. So this is x plus y and this is x minus y. And these 2 points denote these 2 distinct lines. And each point on this line will have the same x plus y and x minus y. And this is how you check how many points are on some diagonal lines. So you create 2 more maps, which is like xy and yx, I call them. And this is like minus x minus y, and this is x plus y. And this is the same, x minus y, and this is x plus y. I add them up here, -1, because I have the same coordinate as well. That's pretty much it for this task. For H is a straightforward task as well. There are some constraints that are given here, and each constraint is, so there are n people, and each constraint constrains 2 people to be somewhere in some camps. So there are, all of these camps are on the x-axis, starting from 0, 1, 2, 3, 4, and so forth, and -1, -2, and so forth and so forth. Okay, so, and each person is somehow constrained to some other person here. So it says like, okay, if I put the first person at position 0, then like the second person has to be 3 units behind this guy, and some other person has to be 2 units in front of the position, or in front of this person. But there could be some other person that is not dependent on any of other persons, so there's no constraint between these two. So it could be like 2 other persons that are constrained here, that are constrained between each other. So they can be anywhere, they don't really matter. Because of the symmetry, because of the generalization of this problem, you could put these persons anywhere, but we need to check their constraints. Do the constraints satisfy the problem? And now that I see that the constraints actually go up 10 to the 9 and there's like 10 to the 5 persons, this would easily overflow. So I can just like, I should be using longs here. I should be using longs because this will overflow. And there's no case against longs, but let me just submit it again. I mean, it gets accepted, but it should fail if you don't use longs. This where clause can be like really up the scale. So what I'm doing here is I'm constructing a graph. I'm saying U has to be in front of V, D units, and V has to be behind U, D minus D units. So in the perspective of U, V is like D units in front, and then V in perspective of V, U is D units behind D. And this is like how I construct this graph. And then I go through each of these nodes, and then if it's visited, I will continue. I want to revisit this component. But then if it's not visited, I will say that it's visited. I will start a BFS. So this is a simple BFS where I put my component here where I'm starting at position 0 because I don't care about this. I put this as position 0, and then I push this into the queue. So the queue, what it does, it's like it says, okay, the queue visited is true for each of these that I'm going to visit in the queue, so I don't have to visit it one more time because this component is bidirectional graph. And then what you say is that for each v, which is like adjacent to Steve, to the current node, has some distance. So this distance could be negative or positive depending on whether or not v is in front or behind. If it's not visited, it's set up where this v is. So if v is where I am, d, where my node is, plus d units. So is it in front or behind d units? And then I push back into the queue v, so I know that I need to visit it again. And then I continue here. But let's say that this node is visited, it's already visited. Even though it is already visited, I have to wonder, is it correctly placed? So if where v is not where I am plus d units, so this constraint between v and t does not fall into is not satisfied, then there's no way to satisfy this, and we just return. So we just break out this test case here. In case that is satisfied, we say, in case everything is satisfied, we say yes. So this this gets accepted, even though now I just to fix my overflow problem. Is this counted like the first solution or the second solution? How is it counted? I'm not sure. Okay, so this is the whole contest. I hope you enjoyed this little walkthrough, just like an hour long. And I see you in the next AdCoder or CodeForces contest. Don't forget to click that subscribe button and like the video or share it with your friends. Thank you guys so much for watching.